mathematicians. Today we're going to be learning about decimals and more specifically about equivalent decimals. Now to get us started, we have 0.3, which can be read as 3/10. And because it's in the tens place value, that means we have 3 out of 10. If it were in the hundreds place value, that would mean we would have a number out of 100. And if it were in the thousands place value, that would mean we have a number out of 1,000 and so forth. So, because we have 3/10, we know that that's 3 parts out of 10 equivalent parts. So, what that means is we have 3 shaded parts here out of 10. Now, we could also write this as a fraction. Because it's 3/10, it's going to be 3 out of 10. So our fraction is going to be 3 out of 10. Now, we're going to take 3/10, the decimal, and add a 0 at the end of it here. And when we add a 0 at the end of a decimal, this should still be equivalent to 3/10. And we're going to prove that that's true. So here, now we have 30 hundredths instead of 3/10 when we add the 0 there. So we're going to see if 30 hundredths is equivalent to 3/10. So we're going to go ahead and show that model again for 3/10. And what happens when I split it into 100 parts, this is what it looks like. And we have 30 parts shaded out of 100, which is equivalent to 3 out of 10. Because look here, that same amount that's shaded here is also shaded in our other model. So that means that 30 hundredths is equivalent to 3/10. So we're also going to write out the fraction for 30 hundredths. Now, we're going to prove that these two are equivalent just using the fractions by themselves and not looking at the models. So we know that 3/10 is equal to 30 hundredths. And we know that 3/10 is written as 3 over 10. We know that 30 hundredths is written as 30 over 100. And if we take our fraction 3 over 10 and multiply both the numerator and the denominator by 10, 3 times 10 is equal to 30. And whatever we do to the numerator, we do to the denominator. 10 times 10 is equal to 100, so that means that these two fractions are equivalent, making 3/10 and 30 hundredths equivalent. So that means if we added a 0 to the end, these two decimals would still be equal to each other. Now, this could be useful sometimes when we're adding decimals, when we're subtracting decimals, when we're comparing decimals. The 0 can be useful as a place value holder or used to help us compare decimals. But just know that these two are equivalent to each other. So let's go backwards. What happens if we start with 30 hundredths and we drop the 0? Would it still be equivalent? So we know that 30 hundredths is 30 out of 100. We know that 3/10 is 3 out of 10. Now let's see if we could go from 30 over 100 to 3/10. We could still do that, but instead of multiplying, we would have to divide, this time by 10. 30 divided by 10 is equal to 3. Whatever we do to the numerator, we have to do to the denominator as well. And 100 divided by 10 is equal to 10. So that means that if we drop the 0 at the end, it would still be equivalent. So we could either add a 0 at the end of a decimal or drop it and they would still be equal. So let's do another example. Here we have 7/10, which is 7 out of 10. And here we have 700 thousandths, which means 700 out of 1,000. And now we added 2 zeros. So let's see if it's still equal. So in order to get from 7 to 700, we have to go ahead and multiply by 100. Whatever we do to the numerator, we have to do to the denominator. 10 times 100 is 1,000. So these fractions are equal, making these decimals equal as well. So we could add 1 0, we could add 2 zeros, we could add 3 zeros at the end. and the decimals are still equivalent. So let's go backwards now, and this time we're going to start off with 700 thousandths, okay? And then we have 7/10 here. Now, in order to get from 700 to 7, we have to divide by 100. Whatever we do to the numerator, we must do to the denominator as well. 700 divided by 100 is equal to 7. 1,000 divided by 100 is equal to 10. So these two decimals are equivalent. We could add zeros at the end, or we could remove the zeros at the end, but only if they are at the very end. If we had 0.007, we cannot drop that because that would not be the same thing as 7/10. Alright, so let's do another example. Here we have 35 hundredths, which means 35 over 100. And here we have 350 thousandths, which means 350 out of 1,000. In order to get from 35 to 350, we have to multiply by 10. 35 times 10 is equal to 350, and whatever we do to the numerator, we do to the denominator as well. 100 times 10 is equal to 1,000, so these two decimals are equivalent. So again, you can add a 0 at the end of the decimal, and it will still be equal. Now let's go backwards. We have 350 thousandths, so 350 out of 1,000, and we have 35 hundredths. So 350 divided by 10 equals 35. Whatever we do to the numerator, we must do to the denominator. 1,000 divided by 10 is equal to 100, so that makes these two decimals equal to each other. Right? Here we have 43 hundredths, which is 43 out of 100. And here we have 4,300, and that's in the 10,000ths place, so it's 4,300 10,000ths. So that means we have 4,300 over 10,000. So in order to get from 43 to 4,300, we have to multiply by 100. Whatever we do to the numerator, we must do to the denominator as well. And 100 times 100 is 10,000, making these two decimals equal to each other. Right? So finally, let's go backwards. And this time we're going to start with 4,300 10,000ths, which is 4,300 out of 10,000. And then we have 43 hundredths, so 43 out of 100. 4,300 divided by 100 is equal to 43. Whatever we do to the numerator, we do to the denominator. 10,000 divided by 100 is equal to 100, making these two equivalent. So remember, you can add zeros to the end of a decimal and remove them if they are the very last thing. If the 0 comes before a digit that's 1 through 9, you cannot drop it because then that would change the value. But you can add or drop zeros to the end of a decimal. And that's it for equivalent decimals.